Good afternoon, everyone. Welcome to our webinar on object type libraries, the second in a series of webinars given by Semmtech with regards to using linked data solutions for various data management issues, specifically for asset data. And today we'll be focusing on the use of object type libraries for asset data, getting your asset data across. Let's see. So I'll have a brief agenda. So first we have an introduction, as usual, about what we'll be discussing today, and we'll be discussing some asset data dilemmas that we can identify or have identified as Semmtech with regards to the management and the exchange of asset data between different parties and different applications. We will, of course, discuss object type libraries, what they are, what the differences are between different object type libraries, and why they can be so useful for asset data. We will also discuss a few use cases, some examples of issues with regards to asset data and how an object type library can be used in order to improve the processes with regards to asset management. And finally, there'll be some things to keep in mind. And in between, there'll also be some demos about our object type library software. So briefly about me, who's this face? Well, my name is Stuart Edelenbos. I've been working at Semmtech now for 5 years. I'm a specialist with regards to library management, hence why I'm also giving this webinar on object type libraries. Now, in case you're unfamiliar with Semmtech, or perhaps you've missed the first webinar, we are an information management consultancy firm specialized in, well, in brief, the engineering industries. As you can see, construction, infrastructure, water, energy, aerospace, and offshore and shipbuilding. Lots of different clients with different roles with regards to these different types of assets. And although the content of all these assets of these industries are different, we do think that they sort of share the same issues and that we can obviously share with them the same sort of solution. Hence, why object type libraries can also be beneficial for parties within these different industries. Okay, now time for the introduction again for this webinar. So a brief recap of our first session where we spoke about linked data more specifically or in general, and how that can be used to benefit your asset data management. We will today be more focusing on object type libraries within the context of linked data for asset management specifically. So we will be discussing, as I showed in the agenda, what the dilemmas are with regards to asset data management, what object type libraries are. We'll be dealing with a few examples as well. So without further ado, let's dive into the asset data dilemmas that we as Semmtech have identified within the industry. So firstly, we have our asset owners. Well, asset owners, it's in the name, they own assets, and because they own assets, they want to ensure that these assets are built, maintained, and created properly. And in order to do so, it's best to have an overview of the various types of information available with regards to those assets, not just to these assets in general, which can be railways, tunnels, roads, lampposts, or buildings, or ships, or aircraft. It's also with regards to these specific assets within different phases of their so-called life cycle, because in each life cycle, different information becomes more relevant to the particular assets and as well as the different parties involved with regards to the assets. So, for example, in the design phase, obviously designers play a bigger role, whereas in maintenance companies will play a larger role. Now, in the time that we live in now, where we've digitized lots of different types of information, we like to store and edit this information within computer programs. But of course, we don't just use a single computer program to capture this information of asset information within a particular life cycle phase, but we tend to use different applications at the same time, because obviously some applications are better to be utilized for particular tasks than others. So, for example, let's say we have these sets of assets. So we have assets with names such as a train track, or there's a particular light post, or there's an office space which might have an intersection with yet another object, or might be part of a larger object or a larger system, and might have some sort of coding along there as well. Well, as these assets grow and become more specific and become more precise as to what they are, different sets of information become available. For example, a set of assets, set of aspects. For example, the length, dimensions, materials, dates, colors, etc. And the further along you go in the creation and in the life cycle of these assets, new information arises as well. For example, their location, and who might have installed the particular asset or part of the particular asset. Well, this information is then stored, managed within different types of applications, because, as I've just said as well, some applications just are more beneficial for particular phases, for particular types of information, because that's what they're specialized in. However, although the source of this information, of this asset data, might be stored, or might originate from one particular application, the same information might also be useful, or tend to be used in different applications. So we tend to exchange this data across different applications as well. However, this is not an easy task, and sometimes it's near impossible to do due to this data being stored in different formats, different file types, because the data within these file types, within these formats, is structured differently, because the information is written down in a different way. An easy example could be, for example, the writing of a date. Do you do year, 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 month, month, day, day, or do you do day, day, month, month, year, year, year? And depending on the application, some applications might only want to use one type of format. So you can't just exchange the information directly. You have to transform it, you have to interpret it beforehand. So this is one of the issues that we see with regards to asset data management. There's an incohesion between the different sets of information about assets across different applications, making it difficult for this information to be shared from its source to a different application. So this is the first issue that we more or less come across. The next issue is with regards to asset owners and, for example, contractors, right, who have to, for example, build or maintain the particular assets. Now, the asset owner will have its application landscape with its for its asset data, and the contractor might have a different application landscape altogether. Regardless, the asset owner will have to, one way or another, share the information that he has on his assets to the contractor. Usually this is done by gathering the different information into some form of a container. This can be either just a zip file with different PDFs and Excel files stuck together. It can also just be a whole custom-made file type created with custom-made software, which gathers all the information from different applications together to create one sort of super file with all the information tucked together. This information is then stored in such a container, is then sent to the contractor. Now, it's up to the contractor to then extract this information from the container one way or another, and to then import them and place them into his own application landscape. But partly due to the same issues we have with cohesion beforehand. This isn't an easy task either. Either because, again, we have different sets of applications which might not be able to communicate with one another directly with regards to data due to its the structure, the content, the formats, etc. It could be because the container created is of such a specified, custom-made way that the contractor simply doesn't understand the format and how the data is structured within the container. There's no identification of what's what. There's no explanation as to what's what per se, unless you have a large set of documentation to go alongside this container. And even then, it might not be entirely clear for the contractor to understand entirely what this set of data with regards to the assets entail, let alone to import this properly into its own application landscape. But say the contractor does manage to extract the information properly due to lots of hard work, perhaps by creating its own custom-made software to fit on his own application landscape, maybe by spending lots of hours with lots of personnel reading and then transcribing, transforming, or copy-pasting information according to their own application landscape. Then the point arises where the contractor will have to share his additional asset information, because some light bulbs, for example, might have been changed, or he might have done some design changes. Something might have been built, and you want to know when, where, by whom this has been built, and the asset owner, of course, wants to have this information. So then the asset information is then stored into a container yet again, and sent to the asset owner to then extract into his own application landscape again. But because, as I mentioned, because it was a rather trivial task for the for the contractor to extract the information, to interpret the information, it's possible that somewhere along the line, when transforming back into a container, into a file folder, some of the information might not make sense, might not be able to be exchanged with the asset owner's own application landscape. So then errors have been made, wrong data or ill-equipped data has been transferred, and then the asset owner at the end is then stuck with data it can't use. This is another very clear example of issues that we see with regards to asset data management in the various industries. Now, what at the core are the causes for these issues? Well, first, we identify that the data is unintelligent. And by this, we mean that, for example, say you have two different applications which have two different table structures with this set of information in it. And we can then extract this information from these tables as follows. Now, we, as humans, as smart beings that we are, might be able to look at this information and recognize particular types of information in these information sets, right? So we can identify that, for example, some information with regards to things in meters and millimeters will have to do with some sort of dimension. Perhaps they're both heights, perhaps they're both widths. We don't know exactly, but at least we know they are dimensions of some sort. We can recognize that something which is called lamppost 45 might be the same thing, or could possibly have information similar to something which is called AX001C, because that might be the code versus the name of the particular physical object, being an asset usually. We might be able to see that these two dates that are written down here are actually the same, but just written differently. And we can also perhaps extract the information that Pete's Builders Incorporated and Peter Janssen are entities in the sense of persons or organizations. It might even be that Peter might actually be working for Pete's Builders Incorporated. But this is what we can do. Computer programs, however, from the get-go, they can't necessarily understand what's what unless we hold them by the hand and tell them explicitly what's what. For computers, in the end, data or information strings, so to speak, is just that. It's just loose pieces of information without context necessarily, unless we explicitly make it so for the application. Not just what the separate information bits mean on their own, but also how, if at all, this data is related to one another. Computer programs simply can't do this without additional help. So the data itself, usually in these applications, is unintelligent because there's no meaning necessarily to what's what. There's no structure necessarily as clearly as to what's what, or why, if there is a structure, why the structure is as it is. There might be no meaning or semantics, a word I'll come back to just now, without making this information, these relations, this meaning explicit. The second cause that we can recognize is that data is disconnected. This is in part built upon the previous idea of the data being unintelligent. So say we have two different applications with similar information of the data set that we just had. And perhaps in these applications, the data is structured in a particular way. They are related to one another in a particular way. Now, say that we have information in the one application which has, for example, the information as to where something was built on a particular day, and we want to share this information to our other application. Without necessarily knowing what this particular information is for the other application wouldn't per se know what to do with this A6 LI 46.2. There's no, without knowing exactly what this is explicitly, the other program won't know explicitly where to put this information. In other words, data is disconnected. We might have two different structures which contain similar information, but it's not made explicit to both applications what's what. And finally, data is difficult to exchange. So as I tried to illustrate earlier, we have the asset owner and the contractor who need to share information. They often do this with a whole set of agreements as to how something is to be structured when sending the data across from one party to another, and it's filled in a container of sorts. And in this container is usually a rather complex model, because it's a complex large set of data which is to be related to one another, and has to be interpreted by the contractor. However, we also notice that not only this being difficult to do on its own, it's not just that with one set of assets or in one particular life cycle or in one particular project this occurs, but it has to be done on several projects and several life phases of perhaps the same assets or similar types of assets owned by the same asset owner. Yet in every iteration, in every cooperation, we notice that the container used and the structure used tends to change every now and again. So every now and again, you might sort of get into the flow as to how to exchange the information, but then in the next set, you're actually starting from the ground up again, making the exchange even more difficult than it already was. Now, how to solve these issues, right? Well, our solution at its core is simply to flip this around. We have to make the data intelligent, we have to ensure that data is connected, and we have to ensure that data is easy to exchange. So one way to make the data intelligent is to explicitly capture how the different sets of information are related to one another. We do this by implementing specific semantically heavy information models, so that we know that something is of a type of height, which is an aspect of something which is a physical object, for example, which is installed at a particular installation date by something which is an organization, for example. By making this explicit, the data, the information itself becomes more intelligent and also more interpretable, not just by us humans, but also by our applications and computer programs. If we do this across our application landscape, and thus making explicit what's what and keeping things cohesive and similar what's what across our application landscape, we can then make sure that the applications between one another will understand what's what, which then improves the exchanging and interpreting of other applications' data along the way. And making data easy to exchange, we would say then to comply to set of standards, for example, those of the W3C standards, because then you don't have to invent the wheel all over again with every project, with every other partner. And we all then know as an industry, for example, how the information is to be shared and what the information is. Now, how do we realize this in reality? Well, to make the data intelligent, we use our object type libraries. An object type library, as I'll discuss just now, is a library where you define your information in a structured way. There's an information model that you use where you sort of define what's what and how things are connected to one another. And then you publish this in sort of a library form which can then be accessible. By doing so, you've made your information intelligent and interpretable for different applications, so that by publishing it and making it accessible for various applications, these applications will then know that, oh, something, for example, a lamppost is, for example, a physical object. It has a date or can have an installation date. It has particular parts. It can have particular aspects such as materials and dimensions, etc. And when all the applications then know what the information structure is about a set information entity, they can also easily exchange the information amongst one another. And finally, an object type library is published in linked data, so it's in an open standard format such as RDF, which then makes it a lot easier to exchange and interpretable for different computer programs. So then what are object type libraries? Well, in short, an object type library, often shortened as an OTL, is also something as a reference data library. It's an information library. It's a publication where you can store your standardized set of information in this particular setting of your so-called object types. And you can use this for your this information in different software applications to ensure that if we've defined something as in other words, we've standardized something as being of a particular type of information in a particular context with other types of information, and we've standardized how, for example, installation dates are to be written down, right? So year, month, day, for example. If we standardize this, then all other applications which access this library will then know, oh, for our thing, which is a post, its installation date will have to be written down as follows. And if I can't do this as an application, if at least in the exchange from other applications, we will know, oh, this thing called an installation date has a particular format, and this is what this information entails. So object types themselves are so-called abstract concepts. You can't point them outside, you can't grab them, you can't lift them. They are conceptual of nature, they're abstract, they sort of exist in the clouds of our minds. So for example, if we have a lamppost, so a lamppost is something we have in our minds that we can think of when we see a lamppost. So we have sort of this prototypical idea of a lamppost in our minds, and various lampposts that we see outside, for example, are all of that type. So a lamppost outside, or all different lampposts outside, are all of the type, are all classified as, or all are types of a lamppost which we have defined. So we've defined a type, right? A lamppost which is something on a pole which emits light, and all these things outside are all things on poles which emit light, because they are all the type of lamppost. So how does this come together in an object type library? So we describe what's to be registered by computers. So what information of our lamppost is of interest for our computer programs. For lamppost as an example, but of course for any other type of asset. And how is this to be registered by various applications? It's always related to a standard, for example, the Dutch NTA 8035 standard, because then we all collectively know that something is when we say that something is a physical object, then we all know that what a physical object is. For example, a lamppost is a physical object, whereas pouring concrete is an activity, right? Not a physical object. And if we relate to a standard, then we can all understand one another when we're talking about something which is a physical object. It's meant for software processing and for data exchange, because we sort of have a communal language conform this standard which tells us what something is and how to interpret it. Then we have some examples of different types of object type libraries in the field today. So there's no single type of object type library. We have different types of object type libraries to suit different types of purposes. You can have something as an integration library, so sort of a connecting piece where we all connect to, so where we all agree as to what something is. A classification system to say, oh, this is a lamppost indeed, and this is a car, or this is a ship, or this is an aeroplane. A dictionary library where we sort of have a list of terms which explains to us, oh, you've used the term car, I don't know what this is, or a combustion engine, I don't know what this is. I have a library available to read up what a particular object is. A product catalog, which explains, in this example of Siemens, what products they have, what types of objects these are, what they are made of, perhaps by whom they're supplied by, or built by, or what the materials are, etc. Besides different types of, or these different types of object type libraries, they differ in various characteristics. One of the big characteristics which they can differ is content. So you can have something which is a list of terms, right, or just words. So if I say we have something which is a lamppost, then I write that down in my list of terms, and then we can agree upon that we use the term light post instead of lamppost, or instead of lantern, etc. You can also add definitions to them, so that besides just the term, we also have a description of what this particular thing is in form of text. You can also have content in the shape of a taxonomy. This is we notice one of the more difficult things for people to really understand. So a taxonomy is just a hierarchy of types. So if I define something as being a bridge, for example, then something which is a drawbridge and something which is a swing bridge, or a hanging bridge or an arch bridge, are all of this particular type of, are all of the same type, namely bridge. And things that I define for this type bridge are then also applicable to these other subtypes of bridges, right? So if I say that a bridge is always has a deck, for example, then all my subtypes, so my arch bridge, my drawbridge, etc., will all have something which is a deck, and they might have their own special information separately as well. They can also have information in the sense of aspects, right? So these are your dimensions, your colors, materials, etc. Then we have a list of parts, not to be confused with our taxonomy. So parts is, again, a hierarchy in the sense of something as a whole which has parts, and these parts can then themselves have parts as well. So if I have my bridge, it has a deck, for example, or if I have a lamppost, it somewhere has a light bulb or a fixture, which in its turn will have some form of casing, I presume, etc. And then finally, you can also have content in the sense of links by having them link, for example, to other subjects. So not just physical objects amongst physical objects, but also physical objects amongst other things, but also information stored in one object type library linked to things in another object type library, which is one of the key points of using object type libraries in the sense of linked data, which we'll exemplify later on. Another thing in which object type libraries tend to differ is in the sense of their schema. Now, this is a bit of a scary bit for most people because it's very technical in nature, these schemas. I'll just go through it briefly and try to explain it as simple as I can. And I'll come back to it later on as well. So a schema is more or less the idea of how formal have I, or informal or implicit, have I structured my information. So the semantics or the meaning between these two entities, how strict have I made something? If you make something very implicit, it's simply saying, oh, I have something which is called a bridge and I have something which is called a lamppost. End of story. But if I sort of specify even further and go up the formality ladder, so to speak, I can say, well, these two things are physical objects, and I have something which is pouring concrete, which is an activity, which is then different than being physical objects. I can also then further on this formality and go, well, my two physical objects, they are related to one another in some form or matter, and perhaps they're also related to an activity, but how, I'm more instead just say it's related to one another. So it's a bit vague still, but we know there's some sort of connection there. And if I go all the way up to formalities, then I will specify what the relation is, preferably come from a particular standard. So I can say these two physical objects are, the one is a part of another, and I can say that activity, for example, transforms or has as a subject the physical object. It might, and the activity, for example, might then have as a result something which might be a document, for example. Then we might also introduce things as cardinality to them, saying, for example, if I have something which has something else as a part, for example, a car can have a wheel as its part. Usually cars, for the sake of argument, let's just say cars have 4 wheels. We can then also add cardinality and say, well, a car has a minimum and a maximum of 4 wheels, thus making my information and my meaning between my information entities more explicit. So just to give a brief example of how this looks, so we have a content in a schema. So let's start with a term, bridge. I can add a definition to it. So I make it slightly more formal, and I've added a different information type as well. I can then create 2 other types of physical objects, right, arch bridge and drawbridge, which are related to bridge in some way, as well as 2 other physical objects. I can also say, well, there are also other things in my information model besides physical objects. So I can have something which is a specification, perhaps, or a requirement, depending on the term you use. Or I have an activity, for example, and I can formalize this step further by saying, well, not only are they related, but they are related in specifically in this way, giving meanings or more semantics to the information model as I go on, adding cardinality, for example. I can also add more information, such as aspects, to this list. Finally, object type libraries can also differ in the sense of availability. We can publish something as a book. We can publish something in an application or a document, so it's something you can read. An application is an object type library which can be used within one application. We can publish something in a platform, so it can be accessible to various applications, or we can provide it as a service, so you can have some form of automation attached to your object type library as well, instead of referring to it directly. Just a brief refresher on linked data. So I've discussed object type libraries, and as I sort of suggest in this slide, you don't necessarily need a linked data format to have an object type library, but it is more beneficial if we were to use linked data. So linked data is just a matter of having an information structure, just very brief also for the sake of time, information structure which is published online, which can then be linked to different publications. So instead of having something in a single file, for example, you can then link information to another file and then use the information stored in that second file alongside your own file in order to expand your information that you can use again then in projects, for example. So an object type library, that's object type libraries in a nutshell. Then what is an object type library in our application Laces? So we have an application called Laces, and now I'm just specifically showing you the application of the library manager. So here I've started very simply on a simple object type library. One of the core values of our LACES product is that we want to make it as user-friendly and easy to use for the end users. So where I said that, for example, the schema can be a scary thing for lots of people to be confronted with when using linked data or object type libraries, you can change schemas or add things to schemas as well. But on the whole, we've sort of taken that issue away from the end user. So you can simply focus on your content and publishing your content rather than having to deal with complicated schemas. So we've already sort of identified that there are things which are physical objects, geometries, functional spaces, etc. And we've already defined beforehand in our model, our LACES model, how these things can be related to one another. So in terms of formality, etc. So you don't have to worry about this as an end user. Now, on this end, we have what we call our kinds tree. So if I just unselect my parts tree, I have my kinds tree. So this is my taxonomy. This is where I define what things are. So I can have something which is a structure, of which I can say we have an intersection structure, a bridging structure, or a tunneling structure, which are types of intersection structures. A bridging structure can be a flyover or a bridge, for example. And then I have different types of bridges, a dynamic bridge and a static bridge. I can have a drawbridge and a swing bridge, or an arch bridge or a suspension bridge, for example. Now, if I, for example, select bridge, then on the right-hand side, I have a sort of details overview where I can see the information of my bridge. So I can see the name here, which I can change. I can add whether or not it's in the English language, for example. I can add a synonym if I want. I can say that a bridge is a bridging structure to cross a body of water, just to keep it simple. If I want to add more information, attributable information besides a description, for example, I want to have a code. I can add something which is a code to my information as well. I can see here that it has parts, which if I open my parts tree, you can see here that it has parts. So this is my partonomy, assembly, decomposition, however you want to call it, tree. So my whole and parts tree. I can add cardinality. So if I say that every bridge has to have a minimum of one pillar, I can add this here. Can also add relations to other types of information. So, for example, if I want, I could select a relation transformed by, for example, pouring concrete. I can add this, and now it's transformed by pouring concrete. Because I've entered this information now on my bridge, all of its subtypes will have the same information because they inherited due to them being part of the same taxonomy. Something I'll elaborate on further later as well is you can also link something to an external source. So CBNL, which is one of those OTLs, Dutch publications I talked about, I can select it, and I can now, I've made a connection to this publication. And then it's Dutch, of course, so I have to do Dutch terms. I can then search its content and find something, for example, if I'm not mistaken, I'm still on dynamic bridge, so I'll do beweegbare brug, and then I'll add it to my element here. So now it's connected to a different publication. And if I just go to this URI, and then it opens the information of CBNL. Now, why this can be beneficial, I'll touch upon later. And if you spend enough time in LACES creating an object type library, you can, for example, have a rather long taxonomy, in this case for infrastructure, with a long assembly, which you can then use on your projects. Okay, returning to the presentation. So some examples as to how and why you use an object type library for asset management. So say we've defined a lamppost in an object type library. We've added some aspects and specified how these aspects are to be written down, so what unit of measure they have and whatnot. And I can then provide access to this information to my different applications. Now, each application then can be, in this case, there is a lamppost out there, lamppost 001. We know it's of the type of lamppost, and thus it will have to conform according to the information that I've standardized in my object type library. Now, each of these applications, because of their own speciality, can then be the origin of the individual assets information, but will do this conform the standardized set of information or standardized type that I have in my object type library. Now, because they all refer to the same object type, and now they've added particular asset information about this lamppost 001, they can now exchange the information, if needed, to the other applications, because they now all recognize that, oh, this information refers to installation date. I know in what box that I have of information within my application, I can put that information in. I can place that information in, and then the information makes sense because we know what it means because it's defined as such in our object type library. So a very simplified example between an asset owner and a contractor. Say the asset owner wants to know something about their lampposts, for example, is the height of all their lampposts 8 meters? For the sake of argument, say that this is information that the contractor doesn't understand on his own, simply because maybe he understands different language, has a different language. He doesn't use the term lamppost but lightpost. Maybe he doesn't deal with the dimension height as a separate dimension, but does everything in height times length times width, etc., etc. Or perhaps it's not just the contractor, but his applications that don't understand it. Well, say the asset owner then has an object type library in which he has to find this particular set of information. Then the contractor will then have asset information in his applications, and then have the applications refer to the object type library so that it knows what's what. Oh, this is what a lamppost is in general. This is what the standard information is of a lamppost. These assets, although they might look slightly different, they are of this type of lamppost, and hence I now understand what, as a contractor, what this information is, and I can then communicate back to the asset owner that I can answer his questions. In this particular example, that the lampposts are all 8 meters. Now, I'll do a brief example of this in Relatix. Now, Relatix is one of the applications many of our clients use to manage their asset information in, it's particular contractors. It's all mostly table-based, etc. So this in its entirety is Relatix, but this little widget here, this is an add-on that we call Fetch. Now, this add-on is linked to my large object type library here. I somewhere have lamppost defined, and in here I can see that I've defined that it has a height, and this particular type of lamppost, all of them have a height of 8 meters, for the sake of this example. Then we go back to our add-on. Now we can, this is all based on the decomposition, so the assembly. So if I click this open, I will see the parts of a lamppost, but I'm not too interested in them today. I just want to have a lamppost. So I can now extract this information from the OTL and so-called import them into this Relatix environment, creating a copy of the information. So if I click on it, it opens this detailed page where I can see that it's copied the information in the sense of description. It refers back to something with a URI, so I can identify it back into what it is within my object type library. And I can see that it has an aspect with the value 8 unit meters. Now, I've already created some assets, single assets in this environment. So first, say I'm as a contractor who is designing this whole shebang. Wait, why can't I? Maybe if I click it. So I can say now that all these separate lampposts, which are outside, or in this case, are still on paper because I'm designing them, are of the same type of lamppost. Now I have a check table here, which will tell me that none of these have the aspect height. So if I click on this one, for example, you can see that it doesn't have any aspects at all. So then I can say then, well, I'm designing assets conform this particular type, and therefore they should all have let me press this button again. They should all have assets of this particular type. And of course, during the webinar, this bit doesn't work, although it did 5 minutes ago. Well, skipping that bit then, I could then forcefully usually push this information to these individual assets. Now let's see if it will comply with my other set of information today. So say I have an existing asset which has a different height of 7 meters. Because I said no, the asset owner says no, all my lampposts have to have this particular value. I can now see a check that something isn't conform the standards asked by the asset owner. So then as a contractor, I can then take action and perhaps replace or fix this particular lamppost. So this is just a very basic example of how to apply information from the object type library into a particular application. Now, linking to other publications. So I just gave you an example in Laces how I could link to other applications or other publications. So now the question is why? Well, as I said before at the beginning about different types of object type libraries, you have different types of object type libraries for different purposes. We can also have a different type of published library altogether, a specification library, something which we'll discuss in the third webinar in 2 weeks' time. You can imagine that there's information stored in these different object type libraries because it suits that particular need for that particular library. So we can have one object type library, for example, for the asset owner, right? We have a lamppost and it has a height. We can have a product catalog somewhere else, which will tell us, well, there is this light post of type A that I can build for you, or we have them lying around in our warehouse that you could use. And there might be some standard or norm which dictates that all lampposts should have LED fixtures. Well, if I can link these together, then when I want to apply the information via my object type library, so I only have to link my applications to one library, I can then use the links that my object type library has to these other publications to extract information from there suitable for the needs of my own applications, so that I can still say that everything I have on my application, on my projects or in my assets is still according to my own lamppost, but I am using I'm using these norms or requirements to which my lamppost should comply to as well. And even though I want something which is a lamppost, I am building lampposts of this particular type according to this product catalog specifically somewhere on the map. And these can be of different entities. So for example, Semmtech could have its own object type library linked to a particular ISO standard published set of specifications. And perhaps we could link to the Siemens product catalog, for example. Or as an asset owner, you might have a different variety of object type libraries yourself, because they have different needs. You might have an object type library which defines objects from the perspective of designing and one from the perspective of maintenance, right? So different functions might be of importance, different aspects might be important. You might have a different taxonomy built. So instead of going static bridge for bridge to static bridge and dynamic bridge, perhaps for your needs and purposes, you go from bridge to rail bridge and traffic bridge, and then you have your traffic dynamic bridge and traffic static bridge, and your rail dynamic bridge and rail static bridge, for example. Whereas in your other maintenance library, this difference is done differently. Or your contractor, or as a contractor, you could also have your own object type library to suit the needs and purposes of your own information needs and link to the object type library of the asset owner. So you can still say, oh, the thing that we call a light post is the same thing or related to this thing that the asset owner calls a lamppost. We will still use this term on our own applications, but because we're working with this asset owner, we will then comply to their needs, which we can then trace back via the link between the different object types, object type libraries. So this is why you'd want to link to other publications, and also why you don't want to put everything into one separate object type library. You can split these up to suit different needs and purposes, and also to use the object type libraries published by others already if they have information relevant to you, and not simply copy them or try to reinvent them altogether if it's not necessary. So finally, to round things up, we have some things to keep in mind specifically when it comes to managing an object type library. So when I mentioned that we have different types of object type libraries, and the different types of object type libraries suits different needs and purposes, this is very true, and depends on, of course, what you want your object type library to be for and how you want to use it. One of the things we've identified as Semmtech is these 5 levels of ambition with regards to using an object type library. So on one hand of the spectrum, you can simply say that we want all that we want for the use of object type library is to create uniformity, or you can make something very intelligent in which you don't just have a published set of information, but a published set of information with some APIs around them, which can then do some artificial intelligence work for you. For example, you can directly ask the question, I have this asset, does it conform to all the things, all the specifications and requirements, etc., and it can give you a yes or no answer. Now, uniformity is simply if you want to use the same terms on across your project or within your own application landscape, for example, which is why you could simply use it within a document format and send this around to those using the information set. The next step is because you want not just have some uniformity in your information, your definitions, etc., but you want to reuse this information time and time again. For example, within one application, so you can build an object type library for the use of an application, or even within one application, or if you have multiple applications, have different object type libraries in each application. You can also make it, have as an ambition that you want to have an object type library to be reused across different applications or within different parties, different life cycles, etc., but from one single source. You could also then have an integrated object type library where you have different sets of information, so different libraries which are interconnected. And finally, as I said, the intelligent one where you can sort of have automated verifications and validations and whatnot, designs perhaps even by adding some clever artificial intelligence work around your datasets. Now, when we talk about management of an object type library or the creation of an object type library, we see 3 main steps, which each has their own set of use cases to keep in mind when creating or maintaining an object type library. The first is capturing your information, so the content in the model. What is it that you want to have in your information model in your object type library? So what is the domain? What is the life cycle that you want to capture? To what level of detail do you want to go with your content? The second is the sharing. So how do you publish and make your information available? Is it just a list that people can look up and read, or is it something people can access or their applications can access immediately and perhaps extract information from, perhaps even add information to it? or how to apply, that's the third step, the information. So if you have granted access to the information, how do applications then use, or other users use this information? Is it grab the whole thing and copy it onto the application? Is it a matter of referring to something? Is it to expand the information on your application, etc., etc.? So also when creating an object type library, do remember that the why, what you are trying to create, who will end up using it, and how you're going to apply it. Also, don't make your object type library too general. Don't put too much in it. And also, if it doesn't suit the purpose, don't keep things too shallow with depth of information. Also, don't keep it too specific. So if you don't need to know all the nuts and bolts of your lamppost, don't add that to your object type library. Finally, in the last minute that we are of this webinar, just some closing comments. So firstly, are you inspired about using object type libraries for your projects or for your assets, or about your software? Well, then contact us, because we have software for different sets, different steps within the object type library usage. We offer consultancy, so if you need us to configure things, or to capture things for you, or to apply things for you, or to help you along the way with our software, you can also contact us for consultancy purposes. We offer trainings, so this is just an hour where I crammed in 4.5 days work of trainings for you. So if you are interested in those trainings, you can also contact us for those. You can also start creating your object type library today. So if you want to contact us because you are interested in using laces that you saw today and in our previous webinar, you can receive a trial period for laces, and then you can try it out for a brief period and see if it suits your use case, for example. And we have another webinar coming up, third of this installment of this series, on November the 6th, with regards to specification management and how linked data can be used for that. So that was it for me today. Thank you all for joining us, or for joining me in particular. Hope you have a good day, good weekend, stay safe, and hopefully see you next time. Thank you very much.